Hello everybody and welcome to the factoring binomials. We're going to first start off taking a look at the difference of two squares, and then we will move over and take a look at the sum of cubes and the difference of two cubes. This becomes kind of like for the first part, it's pretty straightforward. We're going to do some stuff similar to what we did in section 6.3, and kind of in section 6.3 we did pattern matching, basically is what we did. So in this video we're going to kind of do pattern matching, especially when it comes towards the end. Towards the end of this video, when we get to the sum of two cubes and the difference of two cubes. But I would like to just start off by method of introduction. And let's just take a look. Again, if we have these A's and B's, again, are just placeholders. Something that's in the form of these two binomials. And again, let's just note that if we product these together, so A times A is A squared, and then A times a negative B is minus AB, and then B times A is plus BA, and then B times B, it becomes minus B squared. And let's just note with products that we can rewrite these products, especially this one, as plus AB and then minus B squared. And so notice that these guys subtract out and we're left up with A squared minus B squared. So now the question is, given something in this form, can we go back and rewrite it as the product in that form, A plus B, A minus B? So again, the game becomes pattern matching, if you will. So let's take a look at a quick example, 4x squared minus y squared. So if you'll recall, back in chapter 6, I had you grab the first term and write the brackets, in section 3, as something squared. And then the question is can we rewrite this first term as something squared? And notice that we can rewrite this as 2x minus, and now can I come over here to this second term and write this as something squared? And obviously we get the y. So notice now, that being the case, since I can write this, 2x now is what we're calling A, and y is what we're calling B. So let's just recall that we now have to put this in the A plus B, A minus B, or, if it floats your bubble, A minus B times A plus B. So now the idea is pattern matching, so we just match everything up. So A is 2x, and B is y, and notice that A is 2x, and B is y, and then we're done. Again, you can FOIL this out. 2 times 2x is 4x squared, and then we get a minus 2xy plus a 2xy. Those cancel out, and then we get our minus y squared. So we end up with what we started with. So let's observe 1 minus 9x squared. So again, I have a difference. So the question is, do I have a difference of two squares? So let's just compare this real quick to something like 1 minus 5x squared. So notice there's no number, and we're not going into square roots at this point in time, but we're talking about what we call perfect squares. Perfect squares. So the difference of two perfect squares. So again, one, that's pretty easy. That's just going to be 1 squared minus, so now we have this 9x squared. Okay, so hopefully we can see that that's just going to turn into a 3x. But this one over here, notice I get my 1 squared minus, well, I get my x, but notice there's nothing to do with the 5. So what I'm saying at this point in time is that this is not the difference of two perfect squares. So that's what we're looking at factoring, is the difference of two perfect squares. Okay, so now this just defaults down to 1 minus 3x, 1 plus 3x. This is always the case. Always, always, always. Okay? Now let's take a look at something like this. How about a to the fourth b squared minus 9? And at this point, what I'd like to do is to encourage you for rules of exponents to see page 315, objective 3. So objective 3 talks about something that's in the form a to the m raised to the n power, okay, which says that if we have a to the m raised to the n power, that we can product these two exponents. Oops. A to the m n. All right, so for example, if you have x squared raised to the fourth power, so by definition this means x squared times x squared times x squared times x squared. And notice that when you have a product, you add the exponents, which is x to the 8th. All right, but let's just notice that if I just said x to the 2 times 4, boom, I get that. So that makes life really pretty easy. So the other one is objective 4. Sorry, I think this one is 314. Anyways, so this one's going to be page 315. So this one's objective 4. And that is if you have ab to the m power, this becomes a to the m, b to the m. So for example, if you had x, y to the fourth power, then what we're just saying is you can just easily write this as x to the fourth, y to the fourth. Oops, I don't know why I wrote it 2. X to the fourth, y to the fourth, okay? Because we're going to kind of use this implicitly. So now the question is can we rewrite the first a and b's as something squared, and then we get this guy over here. So the question is, hopefully it's straightforward. B, we can immediately write B. So now the question is, I want to raise A. So what can I raise A? So I'm going to put a dot. What do I raise A so that when I get 2 times 2 gives me 4? Oops, I already gave it away. What do I multiply this dot by times 2 that gives me 4? All right, so hopefully we can easily see that that's going to be A squared. B, quantity squared, minus 3 quantity squared. Seems like I just want to give things away today. All right, so now this becomes A squared B plus 3 A squared B minus 3. All right, so it's just kind of using that implicit rule of exponents. It's kind of what I was trying to get at here. So how about A to the 6th minus 144? All right, so you're saying, oh my God, 144. All right, so it might help us. I think that if we take 1 squared, you're good to go with 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. So I think if you just kind of maybe throw these into, keep these in mind, 11 squared is 121, 12 squared is 144, 13 squared is 169. After that, break out the calculator. 14 squared and above, yeah. So I want you to realize that as I go through this discussion and the next one, that yeah, I've already pre-worked these out and I already had to break out the calculator. But I do know that 144 is 12 squared. So again, can I write the first term as something squared and the second term as something squared? So again, if I write A, then the question is, what is the dot? So 2 times the dot is 6. 2 times the dot is 6. 2 times the dot is 6. So do we agree that the dot is 3? So I get A cubed squared minus 12 squared. So this becomes a cubed minus 12, a cubed plus 12. All right. All right, let's go ahead and take a look at one more example before we move on to our cubes. All right, get to our cubes. And that is, we got 16a cubed b cubed minus 49ab. All right, so in this case, at first I'm seeing I got cubes, I got this, and I'm also asking what is my greatest common factor. So let's just note that if I pull out an AB, which is my greatest common factor, I end up with 16a squared b squared minus 49. Right? And I'm thinking that right now you guys are saying, oh, 16a squared b squared, well, that's just 4ab squared, and 49 is 7 squared. And you're absolutely correct, Amundo. So AB times 4AB minus 7 and 4AB plus 7. All right. All right, I'd like to take a look now at just a couple of these. Again, these are just pattern matchings for cubes. All right, pattern matching for the cube. So let's just note that I'm just going to give this away, and you can see a purple box on page 410. Okay, page 410, that's something that is in the form a cubed plus b cubed. Okay, once we recognize this, it's just going to be a plus b times a squared minus ab plus b squared. So all we got to do is find the a's and the b's, and then a cubed minus b cubed is just going to be a minus b, and then a squared plus ab plus b squared. So the big clue here is, notice that when I wrote these as ab, this retains the same sign, but this one flipped. Okay, that's how we can kind of memorize this. Really, it's just patterns. So notice that a cubed minus b cubed, again, this follows the a minus b form here. Okay, this follows the a minus b form here, and then notice over here it's a squared plus ab plus b squared. So these are exactly the same. The only difference is the sign. So notice that when we wrote the linear terms here, it's the minus, so we flipped the sign on the first one. Notice here it's plus because that's plus, and then we flip the sign here. So pattern matching. All right, so let's take a look at an example here and see if we can't do some pattern matching. So this is 27x cubed, okay, minus 8y cubed. So now the game is, can we write this as something quantity cubed? Okay. So hopefully you can see that 27 is actually 3 cubed. So this becomes 3x. And that 8 is 2 cubed. And we can put a y in here. So let's just note that 1 cubed is 1. 2 cubed is 8. 3 cubed is not 27. 4 cubed is 56. And as far as I'm concerned, after that, you can punch the number in for your calculator, okay? I'm not gonna make, these are the straightforward ones here. So 1, 8, 27, and 56. 27, okay? All right, so now all we got to do is match the pattern. So this one here is in this form here. So let's just note that this becomes a, in this case, is 3x. So everywhere you see an a, you just replace a 3x. And b in this case is 2y. All right, so notice that it's a squared, so 3x squared. So 3x, the whole thing squared, becomes 9x squared. And then it's plus. And then we cross product here. So 3x times 2y is 6xy. And then plus, and then 2y squared is 4, or 2y squared is 4y squared. That's what I'm trying to say. Getting tongue-tied here. Okay. So again, hopefully you can see this is just some pattern matching. So x cubed, y cubed, plus 216. Okay. All right. So again, this is the sum. So the question is this the sum of two perfect cubes? That's the question. And to answer that question, if we can rewrite this like this and fill in the blank, then the answer to that question here is yes. So x cubed, y cubed, can we agree this is just xy? So now this is where you get to play the game. So far we made it up to 4. Cubed is 56. So the question is, what is 5 cubed? Does that equal 216? The question is 6 cubed. Does that equal 216? 7 cubed, until you hit pay dirt. So I'm hoping that if you've got your calculators out now, you've been doing a little button pushing, and you will see that this is actually going to be a 6. Okay? So again, all you have to do is come back up here and pattern match. So we got this guy here. So notice here is A, here is B. So now we just play the substitution game. So xy plus 6. So now it's going to be xy squared, which is going to be x squared y squared. Now we flip the sign, minus. So product the xy and the 6, so we get 6xy. Plus, and now we square the b, which is a 6 squared, which is 36. Okay. All right, so let's see. It takes care of that example. So let's do one more example. I got one more, and that should pretty much suffice and get us through, and we can work a few things out in class as well. All right, so if you'd like, you can go ahead and pause this video, try this one out on your own and see what you come up with, and then come back and check your answer. How about 8a cubed plus 512b cubed? All right. So if you'd like, go ahead and pause the video and do your own pattern matching and then come back. Okay, so the question is this the sum of two perfect cubes? So is there something that I cube it and I get 8? Well, we know that's in 2, and a goes here. So the 512, hopefully through your trial and error and pushing buttons on your calculator. So for this whole thing, you came up with 8b. So notice here, this is a, and 8b will be b. Okay. So now we get 2a plus 8b. So now we take the a, the 2a, and square it. So we get 4a squared. Flip the sign, multiply these two together. So we get 16ab plus, and now it's going to be b squared, which is 64b squared. Voila, there we go. All right, I hope this helps you out. And again, if you have any muddy points on this video or any questions on this, please bring these to my attention. You might want to specify which example that you're referring to, and that way we can get it addressed in class. Outside of that, I hope this video lecture helped you out, and I will see you in class.